Lab 1, Vidhya Mallikarjunan.
So to introduce the purpose of this lab, we were attempting to create charged tapes and determine how much charge is on one piece of tape. The fundamental principles that are used here are the idea of electric fields and superposition, as well as electric force, which is just the electric field times the charge of the particle in the field, and the formula for gravitational force, which is mass times acceleration due to gravity. The main result of the lab is that the charge in one piece of charged tape is 9.0369 times 10 to the negative 10th coulombs. Just to talk a little bit more in depth about the physical principles being used, the idea of an electric field for a positive and a negative charge are shown in this figure, and the equation for an electric field is also given here and is utilized later in this lab. In addition, as mentioned before, superposition or adding of vectors was also used extensively in this lab, and that was just adding a vector's tail to tip as shown in this figure. The initial setup for the experiment was to charge a piece of tape by first laying down a base layer of tape that was about 20 centimeters long, and then placing an additional piece of tape sticky side down and ripping it up in order to transfer electrons. This was then approached by a hand to verify it was charged. Then additional tape was created and they were placed near each other. The hypothesis in this case was that both of the pieces of tape would repel each other since they were charged the same way and were expected to have the same sign of charge. As expected, when the two tapes were placed near each other, they repelled. Additionally, they were still verified to be charged because when they were approached by the hand, they were still attracted to the hand. And as for neutral objects, they showed some attraction, but not a significant amount. So the next step was determining the sign of the charge. We had already determined that the tapes were charged and that they had the same sign since they repelled each other. So to test this, we rubbed a plastic pen into my hair. The plastic pen is known to gain a negative charge when this happens. And then it was brought near the U-tapes. The U-tapes were observed to have an attraction to the pen, which shows that the U-tapes must be positively charged. Moving on to the next portion of the experiment, we were attempting to essentially create a floating tape by utilizing the repulsion between the two tapes. The general setup is shown here, where the two black rectangles are books. The red tape is the manipulated tape, and the blue tape is the tape that is attached to both of the books. Just to clarify, the system in this case is the tape that is attached to the books. The surroundings include the atmosphere, the books, and the second piece of tape that is being manipulated. Initially, the pieces of tape were 5 centimeters away from each other, and the lower piece was brought until there was a visible repelling effect, which was effectively seen at 2.5 millimeters. We then calculated the gravitational force by taking the mass of the tape and multiplying that by the gravitational acceleration, and then we know that the gravitational force is equal and opposite to the electrical force. Now, knowing what the electrical force is, we have all the information we need to solve for the electric charge, and we did that finding it to be 9.0369 times 10 to the negative 10th coulombs. Because the tape is positively charged, we know that there's an electron deficiency, and the actual number of electrons can be found by dividing the charge we found by the elementary charge, and so we know that there's a 5.641 times 10 to the 9th amount of deficiency in electrons. There are many sources of possible error, including inaccurate measurements of both the tape length and the distance between the two pieces of tape. There's also the possibility of the loss of charge over time due to contact with other objects that might be partially charged. Now, to jump into the first part of the coding of the experiment, we were creating a model using point charges. As you can see here, this is just the electric charge and the gravitational force on the upper charge. The normal force and the gravitational force on the lower charge are not shown here. Here we can see the gravitational force on the lower charge in red and the normal force in purple. And as observed earlier, all of these charges should cancel out, and we can see that in the net force calculation, which is printed here. There is a small y component error, but ultimately it's essentially 0. This model was created by defining two particles with the same charge and mass, and then setting their location in physical space separate as they were in the experiment. Then we found the r and r magnitude and r hat for all of these particles' electric fields, and then calculated the electric field. Then the electric force was calculated for each of the particles, as well as the gravitational force and the normal force for the bottom particle. And then everything was generated, all the forces were conveyed in arrows. The results of the part 2 of the coding experiment can be seen here. There is an error here. I don't know why you can't see my gravitational force arrow, but this is the results that I got. Everything boxed in red is what I changed. Ultimately, I added a Q proton variable. I specified the mass and the charge, and the electric field calculation using the previous piece of coding. I also changed the position in which the tape was located, 2.5 millimeters apart vertically, and each tape being 20 centimeters long. In addition, I also defined the scales based on trial and error. I defined an extra variable called fnet, which I used at the end, and then I also defined the way to calculate electric force just by multiplying the field by the charge. Here at the end, we just defined the total electric charge, which is why I used that fnet variable from before, and the gravitational force, which for some reason won't show up on my screen. And finally, just to touch on those what if and why questions, ultimately, since there's a deficiency of electrons in the upper tape, it would be instead negatively charged, meaning it would be repulsed by the charged plastic pen. They would still repel each other, and they would still not react substantially to neutral objects, and ultimately the floating tape calculation would be very similar. When comparing the different computational models, you can see that there is a significant difference. The line charge model gave a charge that was more than double, so 2.13 times the charge we initially calculated using the point charge method. And I believe the line charge method is more accurate because it accounts for more interactions.